Well, hello, everyone. Thank you for joining. My name is Dr. David Caro. I think most of you know me as the president of Human Longevity, a physician and scientist by training. I lead the radiology group here, as well as being president of our medical group and working with our whole team on precision longevity. So it's my warm welcome to introduce Dr. Eva, who I've had the joy of meeting in person many times. And Dr. Eva is very international and really has been a force not only for our U.S. clinics but also for our satellite clinic in Beijing. She's a clinician and full professor at the Shanghai University of Medicine and Health Sciences and Tel Aviv University, full-time chief associate clinician as well, training at Harvard Medical School affiliated hospitals and Basel University Hospital as well. Leaving out a lot of credentials and affiliations there as well. But I think as importantly has really been a public force and evangelist for precision longevity, having published multiple articles and participated in multiple presentations and blogs, and is really a thought leader in personalized precision prevention and precision longevity. I know recently among our client base, we've had a lot of questions about, biologic age, how to monitor and track biologic age. And we know there's many, many ways of doing that, including measurement of telomeres, measurement of metabolites in the blood, measurements of epigenetic changes in the form of methylation. And we know none of these are perfect, but actually I'm really welcoming Eva, and hopefully you'll address some of these questions about biologic age, because I'm sure at the end we'll have some questions about that. So without any further delay, we'll introduce Dr. Eva, who has a PowerPoint, and as usual, we'll reserve the end of the presentation for questions. But I think really the title of the presentation is, personalized longevity, which interventions are right for me, which is a great title and discussion because, as you know, just doing diagnostics and analytics is only half the solution. We need to marry that with precision interventions, and there's no better person to discuss that than Dr. Eva. So take it away, please.
Thank you so much, David, for this extremely generous introduction. I hope that I can help today with some of the questions that might have been luring with the patients, and I appreciate so much to be on because as many people know, and whoever knows me, they know I'm a huge fan of HLI, and I had the pleasure and honor to work together and collaborate ongoingly with HLI, both in America and here in China, in Beijing. Myself, I'm in Shanghai right now, and when I was thinking about the title and then also preparing the presentation, I knew it's a very, very specific group of audience today who is very literate already about longevity, and there might be just some extra specific questions. So I will try to keep my presentation to the minimum of 30 minutes, and I usually have a problem to do that. So please do stop me so that we have enough time for the Q&As. And without further ado, I will start so we can dive right in. So, apologies. Go. So our topic today is indeed longevity protocol, personalized longevity, because as you all know, it's a field that is the most precise and the most individualized. We do not only want to look at a specific person, but we also are looking at a specific person at a specific point of time. And the longevity protocol has to be both granular and has to be flexible. And the flexibility of changing of a protocol has to be always guided by data. So this is where everything is coming together. And this is where I would like to start off. Of course, I cannot start without mentioning that we have an annual meeting in Copenhagen, and this year also we will have, as every year, the honor to have Dr. Wei Wuhe, the CEO of HLI, with us, but also several other key opinion leaders, where we are discussing really what can be translated from all this amazing knowledge of gerosciences, the basic research of the omics and other testings into the clinical practice. And this year we are also joined with the X Prize Health Span, the largest longevity prize in the history of humankind. Now, talking about longevity protocol, I also would love to mention that the core point, or one of the most core points in this chain, it's a patchwork, but a core component is, of course, the physician. And what we are trying to do is to upskill the physicians in different disciplines to implement longevity components into their practices. So beyond longevity physicians that we are now working on accrediting and making sure that there's a quality control, we are also trying to implement longevity medicine components into respective disciplines so that any GP, any dermatologist, any endocrinologist, cardiologist, and so on know what are the new diagnostics, what are the new solutions, what are the tools of longevity medicine they can use to upgrade even their diagnosis, their prognosis, and of course, therapeutic options. And for those who would like to expand on the news on longevity protocols and also get a little bit of the basics, basics are always great in order then to discern, as you learn so many new things along the way, what's credible, what's less credible, where is there a fine line for your safety. Now, talking about healthy longevity medicine, I'm always saying, for those who have seen me before, you might have come across the slide, and I think it will never change. Healthy longevity medicine is something that is constantly booming, constantly expanding, and it's like the scene from Alice in Wonderland where the Red Queen is running with Alice, running very, very fast, and then they stop and they are in the same place. And Alice is asking, why are we in the same place after running so fast? The Queen is saying, my dear, if you want to advance, if you want to move from that place, you need to run double as fast. And this is a little bit how longevity medicine is currently. So beyond catching up with all the new innovation and findings from neuroscience, from basic science, from AI, from computational science, and many other fields that flow into longevity medicine, the doctors still need to take it to the next level, meaning not only working with patients, doing a way of an N1 trial, meaning working one-on-one individually, and through this also upscale the longevity medicine practice, but also organizing clinical trials and further clinical innovations, clinical evidence base into the healthy longevity medicine. Now, if we are talking about longevity medicine or healthy longevity medicine, we would like to also put the definition right and straight, because there is now a lot of prominence of that field, and definitions might be blurred. So the first term of longevity medicine came across only around 2020, and it came from this paper in Nature Aging by Dr. Kai-Fu Lee, who's the AI godfather, I would say, and Professor Javronkov, and I had a small contribution from the clinical side, where we said, okay, longevity medicine, what is it? We came up with the definition of longevity medicine being the AI-driven precision medicine that is focusing on health span and lifespan. So there was already a first attempt to say this field is really focusing on extending the healthy lifespan, which all of you know is the health span. This is the main focus. And then, of course, for those who want, and if it's a healthy byproduct, then also increasing the lifespan. And it's driven by AI technology, specifically by AI-driven biomarkers of aging, but not only. And then in 2022, Healthy Longevity Medicine Society was established with people more from the clinical side. And here we move to the definition of a healthy longevity medicine, really to focus on the point of health span and redefining the general term of precision medicine towards optimizing health span medicine. It's all about finding the optimal value, the optimal parameters, and optimizing the entity of a patient by targeting age-related processes, which, as you all know, are the main drivers for age-related diseases, and those are really the majority of diseases. And this has to be done along the lifespan. So for at this point, I always say, who are the populations to be targeted, to be interested in healthy longevity medicine? Those are pretty much everybody. We are all aging from the moment we are born, actually a little bit before that. And whoever is not terminally ill or in a highly palliative setting can benefit from longevity medicine, but it has to be adjusted. And more and more we see children joining some of the longevity physicians' guidance. We see a lot of couples before pregnancy, after pregnancy, where we see people across the entire lifespan. And that's the whole point of it. It should contain people from the entire lifespan. And so on the executive committee, we have phenomenal people. But what I'm trying to say with this slide is we have experts who are working on different domains that can also go from credible to very blurred, let's say. So we have Tom Rando working on stem cells, and Professor James Kirkland working on the senolytics, so the substances which remove senescent cells from the body. Near Barzilai with targeted therapies of geroprotectors, repurposed drugs, metformin. Andrea Maya and myself, we founded the society, and Harold Pincus is the chief of psychiatry at Columbia. Now, why is this important? Because very often when we talk about longevity medicine, not at HLI, there you are in good hands, and brain is a very important aspect. But in many other places, brain is a little bit under discussed, and people are a little bit underwhelmed about this area. Meanwhile, it's extremely core. Brain helped us in cognitive health and also mental health, which goes hand in hand very, very strongly. Now, a final moment about AI. I just really want to underline the importance of AI, not because I'm a big fan of it, because I am, but to say that without AI, longevity medicine cannot really exist. And also AI has enabled longevity medicine to advance, and we are looking at still a very, very bright future, I would say, in that domain. So longevity medicine can only be suitable for you when you have somebody, your physician, that can constantly learn and translate the findings with you, use your tertiary digital layer, meaning any data points that you are collecting into creating and shaping and changing fluidly your longevity protocol, and also combining AI and human intelligence together in order really to optimize the longevity protocol, optimize the health span of you, and create a sort of digital extension of yourself. You've probably heard very often the term digital twin, which is a very correct term in longevity medicine. It's basically meaning we are trying to map, to create your digital twin with all the data points that are there, so that we can use that twin digitally and virtually to simulate whether a drug, a supplement, an intervention would work on you, and how much would it work, so you can balance it out with your quality of life, right? Some people do not like to go to the extreme in terms of the longevity protocol, because it also includes lifestyle changes. And last but not least, in order to protect your safety, right? So some of the things you don't want to try, if already on the simulation, you can see that there are potential harms. And as I mentioned, longevity medicine is really AI driven. So we had this amazing development, evolution, or almost revolution. And some of the hallmarks of agings were already published around the year 2014. Hallmarks of agings are the 9 main domains published at that time. Now it expanded to 12, and it could easily expand to hundreds, right? But at least there is a map of the main domains of the aging processes and mechanism that can be then targeted and also measured. And this is where the exact massive explosion of longevity medicine happened from the year 2015 and on, where first deep aging clocks were developed, where we had much more of the omics being implemented in the clinic, out of the lab, and where we were finally able to use AI to read and better evaluate some of the main global biobanks, UK Biobank, Embers, and so on, to gain knowledge on how can we plan longitudinal prospective trials. In simple words, how can we better help a person right now from the knowledge of those thousands of people who have been followed in the past and who had so many data collected that a human brain could not evaluate. So this is where AI helped. And the next development and the next step will be to create large language models. Most of you probably already know that large language models are being developed for longevity medicine as we speak, and very, very well published already in some of the most credible venues, right? So it's not only a discussion or an idea that people have, it's not individual approaches, it's really a very, very credible work that is being done by many credible groups. And large language models in longevity medicine, in medicine in general, but especially in longevity medicine, will really help to bring further automatization and to be a great support, not a replacement, but a great support of a longevity physician to make an even more informed decision and to fuel in all the components that are important also for the patient. So we can come up with a great plan that would greatly help the physical health, maybe even the mental health. But if we do not put the component of patient's wish, patient's feeling for how much motivation he or she has at this point of time, and last but not least, we stratify in longevity medicine the patients also by their willness, or by their motivation to take risks. So I've learned, I'm not from the economic area, but I've learned that in banking, there is also something like a KLP, like stratifying the patient, the person by how much risk the patient is willing to take and how much benefit is then being balanced out. And something like that we have also in longevity medicine. So how much are you willing to take a senolytic that is trialed only in 20 clinical trials, and primarily the evidence is still coming from the animals? It might help, it might not help, right? It might potentially cause some minor harm. No doctor should advise against something that has reported severe harm, of course, but those elements all flow into the conversation and into the modeling, into the shaping. So a longevity physician, in order to make a longevity protocol for you, will also ask you much more questions that we would ask, in a normal hospital setting, and would also weigh in the component of your personal motivation and your personal willingness to take some sort of risk for that protocol. And on top of all that, on top of all the data that are collected from the patient, from the omics, from the functional testing, from all the images we do, from all the lab work, from all the data points from the wearables, on top of all that, we would also fuel into some of the models the habits, the lifestyle, and the environment, meaning you're exposing yourself in an environment. This is your mini world. And we cannot only look at one component, we also have to look at your environment and bring it all together. And on top of that, of course, also the points of brain health, mental, and cognition. So as you can see, it's already a lot when I list it, but it's even harder to put correlations into all of those extremely multimodal heterogeneous data. It's pears and apples and packs of wood and a little bit of plastic. It's totally granular, and yet everything influences the entire your ecosystem. When we can capture all of those data, optimally on a longitudinal base. So longevity protocol should be a journey. It should be a path. It's not 1 year. It's not 5 years. It's your entire lifespan. And along that lifespan, the more data you collect, the bigger is your personal biobank. And people who started to collect that in a very granular way are the ones who will benefit the most and probably will be the first to benefit from the new solutions that are coming in, which is, for example, AI-based drug discovery, which is using this data for much better prediction of your potential risk of developing age-related diseases, and you want to know when it will be, right? You don't want to be constantly worried. So with more data, you can make a better prediction of time when that will happen. And then last but not least, it's important to understand, now it's easier for me to talk about it because everybody knows ChatGPT and most people use it on a daily basis. Now it's easier for us to explain what generative AI in longevity medicine is and was already many, many years ago, way before ChatGPT was out there. The concept is the same. You fuel in all of the data from the patient, again, from omics, from imaging, from blood tests, from behavior, from neurogeneration, from the monitors. You fuel it in, and then specific technologies, for example, deep neuronal networks, DNNs, bring it into a so-called functional objective function, meaning we can ask a question and we will get an answer. One of those questions will be, what is the biological age of that patient? And this is where we are coming to the point of saying, okay, what is actually longevity medicine here? Medicine will always have an arm that is reactive. Treating diseases will probably not disappear, we wish, but it's still an integral part and we need to know how to do it. There is also prevention. Prevention is anything that we know for decades on how to do general screenings, how to detect the early signs of a disease, or to prevent the disease to expand or a recurrence to appear. But per definition, that's already something that is actually detecting the early disease stage, so the disease is already there. So longevity medicine, you might see it as an extra arm to prevention or something that is above prevention, irrespectively of where you position it. The whole idea is really to mitigate the risks of diseases. And how can we do that? So this is basically a graph that is showing what's your journey, what's a journey of a patient through the life. And in the real world or in the sick care model, you basically are born, you grow up, you are being usually evaluated in a range of parameters. You all know the tables, age, weight, we look where the child is on that graph. The same principle continues usually through the entire life. And around the age of 20 to 35, we individually reach a point of the so-called peak optimal performance. And the peak optimal performance is usually overlapping with the time where we are having family planning and professional career. So it's fortunate and unfortunate. And then from that moment on, we have a functional decline that is, depending on the individual, stronger or less strong, irrespectively of the speed of aging and functional decline. Still, the methods are to evaluate a patient within ranges, within norms that are based on population studies. It can be a much more similar population to a patient or a little bit different population. Doctors have to talk to each other. Doctors' memory is limited, and at the end of the day, there is death occurs. The lifespan is finished. In longevity medicine, we are trying to achieve something a little bit different. And again, it's not against sick care model. It's something that is additional and very valuable, even in the sick care setting. Myself, I'm an oncologist and work day to day with very sick patients. And even there, we see that having this longevity mind and also implementing some of the diagnostics is extremely helpful to guide and to optimize therapies for those people. So one thing I also want to mention is very important and dear to my heart is that if a patient is joining some sort of longevity protocol and already has a chronic disease, diabetes, whatever it is, heart condition, or is a cancer survivor, and we have more and more cancer survivors right now. That's just a fact. The epidemics of cancer is there, but we have better therapies. We have plenty of cancer survivors, so they do already have some biological aging damage. Can they also be a longevity patient? Absolutely, and probably even more so than just the healthy individuals. Now, again, in longevity patient journey, we are trying to look, especially even before the moment of peak optimal performance, but usually it's so good to have the data from that peak optimal performance timing to capture them, so that along the functional decline, we can always measure the patient's biological age and also estimate with algorithms what would be the optimal biological age of that patient, and then to navigate the parameters back so we can bring the patients to the optimal biological age at each point of time. So the concept that we have of looking at the biological age rather than the chronological age, it's nothing new. We've had that for decades in the sick care setting. We had this, we called it the have a look at the patient diagnosis, right? We always looked if a patient is advanced biologically or not. But it's so extremely biased. Therefore, having those algorithms and objective measurements, even if they are not perfect yet, even if they are not in many ways validated on longitudinal prospective cohorts, still they do show they are a big help, especially on optimizing the patient journey. And another thing is, sometimes when we have a chronological age of, for example, let's say 70, but the patient is 63, we will calculate the optimal age, and that's usually not bringing back the patient to the age of biologically 20, right? Not at all. That goes against the algorithm and statistics. We are usually bringing the patient to an optimal age, which is often not more than a delta of 10 years, right? So it's also important to understand that credible longevity medicine will always have also realistic statistics based on the algorithms that are being used. And as Dr. Carroll just mentioned before, diagnostics is really a part of the longevity medicine journey, and clinical precision diagnostics is growing. It's a very evolving field, and that's great. And for many years, the question was, why do we do all these diagnostics if we don't really have interventions other than, individualized lifestyle interventions? And the answer is because we need the data in order to identify biological markers, meaning you need to have all this data to identify what to measure once you do a trial on interventions. Meaning we cannot know if an intervention, a pill, a supplement, or any other intervention is working if we don't know what to measure for longevity. And so that has been evolving, and luckily many centers such as HLI and others, many groups, despite all critics, they were collecting the data. And these data are now extremely valuable for the medical field, because based on that huge amount of very multimodal data, again, using some of the old, let's say, old time testing from functional 6 minutes walking test, grip strength, body composition, bone density, and also super advanced technologies, whole genome sequencing, polygenic risk score, full body MRI, all those things, bringing them together in an AI algorithm is actually what's the most valuable for the patient, individually for a patient at a specific point of time. And some of the things that 10 years ago were extremely new and people didn't understand well are now very established. And an example of the polygenic risk score, which most of you will know because you've done it, those polygenic risk scores are now entering hospitals. See, so there is a difference of driving longevity medicine and then implementing it once it's established, and it takes years. Meanwhile, polygenic risk score has been an invaluable tool for guiding a longevity protocol very, very precisely, because we cannot focus on everything. Life is limited, and we need to also set priorities. Polygenic risk score is helpful to set the priorities in managing of the interventions, as is pharmacogenomics. So there is now also many hospitals that are trying to implement pharmacogenomics into their EHR system. Why? Because it's so valuable, because it's so important, because so many people have been on medications that just simply do not work, or at least the dose was not adjusted. So pharmacogenomics is very important in that protocol. But what is even more important is really to have a continuous monitoring. And continuous monitoring is now easier than ever, luckily. Automatization is bringing more abundance and luckily also lower costs. So some of those devices are really, really affordable. Some of them are still, a little bit more expensive, but hopefully the more we will have, the cheaper it will get, and we will be able to engage more people in surveillance and then create even more data to further optimize longevity protocols for all. So it's all a circle. And some of those monitors are very important. There are more and more devices that can track like a mini polysomnography, the sleep, not only in terms of quality, how long did I sleep, what's my score, but really in order to check the oxygenation. Most important thing during the sleep, besides of the sleep being either deep sleep or REM sleep, is how much of oxygen is your brain actually getting. And luckily, some of those devices are now very, very nicely showing us the patterns through the entire night in terms of when are the phases where you don't breathe or you breathe not enough, or how do you respond to high altitude, right? Many patients, they go to the mountains, they never knew that during this time they are just massively hypoxic in the night. And other trackings, most of you know or use CGM, continuous glucose monitors. Now we have also continuous cholesterol monitors, ketone monitors. Many of you are or have heard or are doing intermittent fasting, which is, by the way, one of the very few interventions that have been proven in clinical trials to actually help the health span to be extended. But you want to also know if the regime that you are following is right for you. There's so much information about different regimes, from 16/8 to more I would say aggressive and brutal limitation of the time when you eat. And some people bring it to a very, very short span of 2, 3, 4 hours. Meanwhile, for them specifically, it's mostly non-beneficial at all. So putting a body into moderate stress, hormesis is good, but if you put your body under more stress, you're basically working against yourself. And instead of inducing autophagy, you are basically inducing all the negative impacts of your stress. So you want to know. So what you do, you measure your ketone bodies, at least for a while, and you use that to optimize your interval with your doctor, again, usually not by yourself. We have also very good trackings now, not only of all the vital signs, of the steps and heart rate variability, but also of the use of, for example, vagus nerve stimulation, and many other trackers that are very useful to be used either ongoingly or periodically. Those include also liquid biopsies, which I think are very, very important. And there is the same discussion. Some of the tests are less sensitive. Some of the tests are trained more on people who already had cancer. Nevertheless, I think liquid biopsies are phenomenal and should be applied for healthy and for patients who already had contact with cancer. And why do we need all this? It's because aging is not consistent. It's different on different levels of your body. It's different on your system level, your entire body. It's different on your organ level, tissue level, cell level, molecular level. The whole idea is to understand, at least approximately, how fast are you aging biologically, in which of those parts of your body, and then at large, which of the actual organs or which of the actual measurements are going to be bad for you, and to track them more often than, for example, others. And this is how you end up with a longevity protocol that has to be, as I mentioned, fluid, but has to also implement the frequency of some of the testing, frequency of some of the interventions, and then to really bring the testings that are needed into one place, into some sort of a cloud, some sort of a portal, and especially into one brain of your physician that is following you through that. On top of that, on top of all the data, of the physical hard facts, you also need to implement always the component in this longevity protocol of education. What you don't understand, you are much less willing to follow. And also to bring the education of the ongoing changes, right? Many times we had some supplements who were very praised in the past, but right now we gain new evidence and we say, well, maybe it's not that helpful. Same goes for hormone replacement therapy. I wish I would have more time to expand on that. I don't, but hormone replacement therapy is now gaining a lot of evidence that it is not anymore as dangerous in a sense of development of cancer or other parts. The opposite, mostly it is very beneficial to prevent dementia, to prevent muscle loss, and things that are really advancing the biological aging. And yes, I would like to now move as a closing part to the biological age measurement. As Dr. David mentioned, we have a lot of different clocks. Why do we have different clocks? Because as we mentioned, aging is not consistent. We need to measure in various places in order to get a good map on the biological age. Very often I heard the question, well, which of the aging clocks is the best? There are no better or worse. It's like comparing mother to father. It's a whole combination. And the more we can measure, the better we can make a prediction. And also those clocks are not something you can make a median from. It's not an average. They have different proportions to each other. Therefore, it's good to measure them. It's good to measure them in different frequencies, but we have, for example, biological aging clocks based on methylation, the epigenetic clocks, on blood results, without the need of taking blood. That one I like to use actually very much. We have also aging clocks just based on the facial features of the skin, brain clocks, very good clocks based on the ECG and now even echocardiography. Of course, clocks based on the heart rate variability, HRV, and now even good clocks based on proteomics, lipidomics. That's a little bit more advanced. That's less accessible. But there's a new clock that has just been published in Nature Aging just a week ago or 2 weeks ago out of the group of Brian Kennedy about a medical history-based aging clock, meaning putting all of the clinical data that one can get from the past and from the current state of a patient to calculate the biological aging clock for that patient just based on the data, which is so great because that really brings abundance. And as I mentioned before, those clocks are not connected to each other 50-50. Yeah? We are still trying to understand what is their correlation in order to ultimately come up with what's the most important for the patient with biological age measurement in terms of the speed. How fast do you age? And on top of that, how fast is your specific organ aging? How is the aging speed of one organ influencing another organ, right? Heart, kidney, brain, and so on. And how does it ultimately influence your entire functionality, your performance in that sense? There are many organ-based biological aging clocks, but they are still mostly in the research. But I'm very, very hopeful and very positive, optimistic about them. They have been proven useful. And as I mentioned before, we can also use a lot of those clocks together in order to integrate them and make a bioaging prediction, meaning how fast do you age? But on top of that, you will ask me, okay, my biological age today might be different than tomorrow. How often do I measure? Which one do I use? Exactly, and that's an individual part. Your doctor should be able to help you on that. Some of the clocks are, we could do them even through the entire day. Now we know that the epigenetic clock is oscillating through the entire day, right? But still a trend is to be seen. Some of the clocks you can measure every 3 months, every 6 months, and some of them just once a year because your telomere length will not change that often, right? So this is all important. And last but not least, it's important to understand that your biological age will change when you have a special condition. There was a paper and even went into the public media a while ago that COVID is advancing biological aging pace. Clearly, that's just one of the conditions. We have also seen that pregnancy is advancing biological age, but then the biological age is returning to normal. And we've seen that in many other cases with surgery, with severe infections, but without measuring, you don't know. So we need those measurements and a baseline in order to be able to then see how much is a special event, as I would say, a life event, influencing you and your biological age, and can you recover? That's very useful. So that's just an example, right? This is a hematological aging clock where we have patients chronological age 41, biologically 45, and it's all about where is the optimal value, right? So we are not looking for, here's an example of total cholesterol. Here it's clear that the patient is outside even of the normal standard ranges. But that's not high rocket science to see that. Much more important is to know what are the optimal values for that patient of parameters that are within the norms, but where on the scale should that patient be? And that's something that the algorithm is helping with. And this is just an example of a patient who was a very enthusiastic patient to take a lot of different supplements, overdosing them massively, thinking that it will actually, more helps more, which we know in medicine is absolutely not the case in most of the cases. And he started to take a lot of creatinine and many other things. Creatinine is good, by the way. It's just the dose is important. And he aged biologically, and despite warnings, despite clear outlining of what he should change, he still continued, right? Even added some of the repurposed drugs and aged even more. And this is where he started to listen, because at this point of time, it's already becoming very uncomfortable for a patient who is longevity enthusiast to see that his biological age is growing. And the journey of a longevity plan will include, as I mentioned, a lot of the diagnostics, very advanced, and you know that all from HLI, the continuous monitorings in a specific plan, and of course, supplements. And I'm very happy to answer questions on the supplements in the Q&A session. But one of the questions that you might also ask is, how do I measure the success of my longevity path? Besides of maybe feeling better or feeling younger, looking younger, I think a good way to have an objective measurement is the biological age, because again, the realistic goal is not to make a patient 20 years younger, at least not for me. My goal is to keep the patient at least biologically at the same level, which is usually less than the chronological age, and keep that delta in minus through the entire lifespan. That's my goal, and this is what I see in patients, how I want them to be guided. But sometimes biological age can help us now, again, as sick care career doctors, to identify things that might not be very apparent at the beginning. So I have several patients who came and they could not get pregnant, right? And there was apparently nothing wrong with them, but the biological age suddenly started to show older than the chronological age. And only that helped to actually dig in further. Those who work with those clocks know that the algorithm can sometimes, without apparent parameters, can predict somebody older because there is some autoimmune disease or there is a hormonal disbalance. And so for those patients, it was helpful to actually identify autoimmune diseases that cause them to get spontaneous abortions. So what should one do in the longevity protocol? Longevity protocol is targeting hallmarks of aging on different levels, besides, of course, of the lifestyle interventions, which again has to be followed by data, because one can even do harm with very simple nutritional guidance and very big mistakes with especially intermittent fasting or fasting in general. You don't want to do fasting thinking it's helpful, meanwhile you're putting yourself at stress and losing muscle mass. So it's very important to track. But the other things that you are probably more interested in are the compounds. Yeah, what can you take that will actually help you? Maybe. And here we have different groups. We have senolytics and xenomorphics. So basically senolytics, those compounds who take out or kill the senescent cells, the zombie cells from our body. And then we have xenomorphics, those who are actually modulating some of those senescent cells to be less dangerous, to be less of a waste in our body. And we have many other components, the supplements that are less less established in evidence base, but also probably less harmful, the antioxidants. Now, where is the evidence, and how does this go together with some of the more extensive or further level of therapies, that go to cell replacement or gene therapy or immune therapy, and how also does this integrate with a very, very important component of gut microbiota? Well, in terms of geroprotectors, of the compounds that are helping us to preserve us from a faster aging, we have good databases. This is just one of them where you can check what is the level of evidence in animals and in people, and what is actually helpful. And that database can also, just like any interaction platform, can help your doctor to say, is it good for you? Is this mix of supplements good for you? They interact with each other. Just like any medication, supplements also interact with medication. You need to know what to take using those tools, and those tools are available. And in terms of senolytics, it's a little bit more complicated. That should be that should be done only by somebody who's been working with that and is constantly also checking what are the cellular pathways findings in them. Because some of those naturally occurring senolytics might be beneficial, but also in an overdose, and for patients who, for example, already have some cancerogenic history or are prone to cancer, might actually trigger a bad process. Overall, I think senolytics have a very, very good and optimistic future, and they are actually being trialed on sick patients, very sick patients, patients with triple negative breast cancer, people with glioblastoma, because cancer and aging have the most interactions and overlaps in mechanisms. And some of the xenomorphics and senolytics you can see here. In terms of xenomorphics, those are usually the compounds that you have already been exposed to, and those are also including repurposed drugs. In terms of senolytics, you will mostly just find names of compounds, right? That are still not in the market. So actually, most of the senolytics that are being now trialed have only a compound name, but I would say it's good to watch out and be very cautious in use. In terms of microbiome, the development is also very interesting. So we are moving from this, I will check my microbiome and I will take some probiotics and then I will check it again. We are really moving towards more advanced diagnostics to check the microbiome on the tongue, on the skin, and also, of course, in the gut, but not only, and to check it more often because there are home tests that are much cheaper and one can do by themselves, and fuel it in again into an algorithm. It's a challenge to have billions of bacteria analyzed every single day, but for AI, it's not a problem. And so probably the next longevity microbiome stimulating intervention will not be a molecule, but actually an algorithm, meaning which mix of bacteria strains do you actually need to take, if at all, on a specific day based on your measurement of that day. And last but not least, AI-based drug discovery is something that is important. This is just to encourage you to collect your data because those people who will collect their data will benefit mostly from those developments that are ongoing. If, God forbid, you get sick, you will be able to use your data in order to potentially find a target, find a compound, find the drug or the vaccine or whatever it is that you personally need for your current disease and current disease state. And last slide on brain. For those who are interested, we do have now measurements of brain age. It's possible based on MRI, so really quantitative measurements. And that's been out there for a while, but also other things that are related to brain that we sometimes forget, meaning all the senses, the smell, the taste, the hearing is very important, also vision, and voice, right? So neural NLPs are very important. So natural language processing, how you talk, how is your voice, that has been correlated a lot with dementia, with cognitive decline. It's important. And some of the clinics are also capturing that voice recognition data and storing them. And we also have new frontiers of brain biomarkers. So we know that we have identified some of the proteins that are connected to the cognitive decline, and not only in the cerebral CSF, in the cerebrospinal fluid, right? You don't have to always have a puncture of your spine in order to to identify molecules that might be correlated with your cognitive decline. We can check them now in the blood. It's still quite preliminary, but it's available and ongoing. And with this, I thank you so much, and I'm very much looking forward to the Q&A.
Thank you, Dr. Ivo. As you can imagine, we've gotten a lot of questions, so I'm sorry I won't be able to get through everything. I think we'll go a little bit over. We normally end right at the hour, but I think we'll go a little bit over if folks elect to stay. I'll try and it looks like there's several questions that multiple folks have asked, so maybe I'll get to those first. Actually, the first one is there's a comment on, and I think you're, Dr. Eva, very familiar with this space, but there's a comment about, kind of all of the different interventions that you mentioned. There's recent data from Dean Ornish on Alzheimer's disease, a 5-year clinical trial, which showed that wellness interventions, including a vegan diet, aerobic exercise, meditation, social interaction, can really move the needle and actually reverse, which was really astounding to me and incredible, reverse the trajectory of mild cognitive impairment in people who were, had early disease. And that along with the Lancet Commission's paper in 2020, where it was noted that 40% probably of, Alzheimer's in general is modifiable and in your control, or maybe more to the point, 4 in 10 cases are preventable. I think there's just this accumulation of evidence to suggest that, wellness interventions, including social interaction and exercise and strength training and nutrition and reducing inflammation and increasing insulin sensitivity, can have an enormous benefit, not for folks that are really far along, but for folks that have maybe pre-symptomatic risk or mild disease or early disease. And here's my question. Do you think the same applies to biologic age that applies to Alzheimer's? In other words, where are you going to get the most bang for your buck with all these interventions that you mentioned? And there's all kinds of, rapamycin and NMN and plasmapheresis. Don't you think maybe we can, in some ways translate what we've learned in early mild cognitive impairment in Alzheimer's into our thinking about biologic age, where maybe the best place to focus most of our effort is on some of these interventions? And yes, maybe a pharmacologic or a supplement will help, but maybe we get the most bang for our buck with these interventions. What do you think?
Well, absolutely. I think lifestyle interventions, and maybe lifestyle interventions, not the best word, because people think, oh well, that's what my grandmother told me always. It's really a very individualized optimization of some of the processes, and health is a habit, and no molecule or compound, in my opinion, will fix the health span without having a very good, informed, data-driven optimization of how a person is actually living. So it's all about healthier living, and the paper from Dan Ornish and his team is just once again showing us, look, it's really a measurable thing that you can modify. That includes biological age. That includes health. Yeah, I would call it this way, or some people say this, the sex span, and so on. You can modify a lot. And the main domains of optimizing sleep, nutrition, cognitive performance, and muscle mass and or exercise is just really a very important fundament. If this is not existing, probably nothing else will help, even with the most advanced therapeutics. We can only further optimize and enhance with those. Absolutely.
Yep. No, thank you. That makes a lot of sense. And I couldn't agree with you more that, in some ways, when you say wellness interventions, yes, you think about some of that sort of kind of, handed down advice from family members, but really it is so much more complicated than that. And even if you think about the different levers of wellness interventions, mitochondrial support, reduction of inflammation, insulin sensitivity, I think you really have to use data to understand where to start, because you can't do everything. And for some people, inflammation is the place to start, gut inflammation. For other places, it might be strength training, aerobic conditioning. For others, it might be insulin resistance. For others, it might be oxidative stress. And you really have to let the data, guide the direction that you go. So thank you for that. Let's see some other questions here. Actually, this is coming up quite a bit in our practice recently here, both in San Diego and San Francisco. What are your thoughts, Dr. Eva, on rapamycin in general?
So I can only, remain very general because I don't, and I see a lot of questions here. Do you recommend this? Do you recommend that? I
Right.
don't recommend nothing on a generic base. I recommend to have a very individualized approach. And for some people, some of the things might be beneficial. For some people, no. And in terms of rapamycin, so I'm hopeful and optimistic. It's really one of those repurposed drugs who've been trialed nicely also on people. With the work of John Manick back in times, we still have very good evidence that rapamycin, if used correctly for the right patients, really can at least mount the immune response, really can help, some of the neurostimulation, can help on cognition. So in general, I would say it's a drug that I would love to see in clinical trials more, and especially on healthy people. I'm still waiting for the evidence. And another thing I would like to say is for those who potentially consider or maybe even are taking rapamycin on their own, please do make sure you have somebody to actually guide you, because some of the potential side effects might actually harm you. And you don't want that, right? For your health span. So if you already determined that you want to risk and to take it, please make sure you have somebody at least to track you, at least to measure your sirolimus level, in the blood, at least measure your level of microbleeding in your colon. Make sure you at least look at the red flags and try to also measure your levels so that you do not overdo.
No, thank you. I think that's great advice. I know all of us in the longevity space get questions just like that from, clients or just the general community. Do you recommend this? Do you recommend that? And, whenever I give talks, I say, look, probably the most important suggestion or biohack or recommendation for increasing your healthy human lifespan is to focus on my number one suggestion, which is data, your data, and lots of data. And, this idea that, folks are doing blogs and recommending certain supplements or certain, pharmacotherapies, whether it's NMN or sirolimus or rapamycin, generically is just crazy. We're all different, right? And we have to let the data guide which of these interventions will work on a personalized basis. So I couldn't agree with you more. And I think the other thing that's missed by so many folks is, everything has potential side effects, and more is not necessarily better. And most things in biology are U-shaped. Too little is probably not good, and too much is not good. And I think we have to be really careful. And I think the other thing that's missed is, even supplements have side effects. So just because it's not ordered by a doctor, it's a supplement off the shelf, many of those can have side effects. So I think it's really important to engage with your longevity clinician, in our practice, to really see what's right for you. And I really would discourage folks from thinking that, because, you heard in a blog post from Peter Diamandis that rapamycin is the next greatest thing. I would really discourage that sort of approach or thinking. And so I'm glad to hear you're on the same page. Just a couple more questions here, and then we'll close out. And I really do apologize that we can't get to everything. This notion of sex span has come up. What is your thoughts on that, Dr. Even? I know you had mentioned it just briefly as well.
Well, I think, what can I say? It's very important. And I'm very happy that we have a lot of colleagues talking about this more and more in all domains. So previously it was more focused on menopause. Luckily, something that I'm very passionate about is really to focus on the andropause. So males have exactly the same thing as women in terms of changing the hormonal balance as they progress in chronological aging, and to optimize the hormonal homeostasis. So really the right balance at the right point of time for people is just so extremely important, not only for the reproductive, not only for actually the libido and whatever is associated with that, but really, but really also how it influences your cognition, development of dementia, losing of the muscle mass, being prone to develop some of the cancers. Interesting studies have now found that actually women who have been on hormonal replacement therapy, identical, of course not synthetic, they actually had a much lower incidence of cancer. So probably that's even protective, and that's important to know and to follow. Yeah.
No,
So
thank you.
that's my notion.
Yep. And I think, as you know, we have a lot of experience led by Dr. Tina in our group in not only women's health, but hormone health in general and hormone optimization for men and women both. And I think we also take that very same judicious approach, which is that, not everyone's a candidate. And we, of course, more is not necessarily better. We don't want to supplement above and beyond the normal range. We want you, in many cases, to get to sort of high normal. But even for some individuals, that could be, wrong-headed. So, for example, if you're a male with a predisposition to prostate cancer, maybe elevated polygenic risk score or BRCA mutation, we have to think very carefully before putting you on, testosterone replacement therapy. So, I think it just highlights the point that we continue to make, that all of this is personalized and individualized, and it's super important to get it right. Last question, and again, I apologize, won't be able to get to everything. And Eva, I think your reputation, having been in the oncology field, is well known even to some of our audience here. And so the question was, given your background and experience in oncology, do you think chemotherapy advances biologic age in general? And if so, are there any measures for patients to reduce this effect? And I know you can appreciate, just like in your practice, in our practice, we have a lot of folks who have been through, our cancer survivors, and even many of our clients who are actually going through cancer treatment and working arm in arm with these clients. And I think what we try and do in that case, we're not oncologists. We don't try and get in the way of the oncologist working with the patient. What we do try is optimize cellular health and really optimize someone so that they're really, vital and as strong as they can going into chemotherapy or radiotherapy or immunotherapy, whatever it is. So I'd love to hear your thoughts on the biologic age in general for chemotherapy, and if so, what measures can you do to reduce this?
Right. I'm so happy you picked this question, David. Thank you so much. And it's coming from a dear friend. Actually, I see that she's also a doctor, and absolutely. So currently, and we have some data on that. We will hopefully publish soon. Chemotherapy, of course, is advancing biological age, as is surgery, as is radiotherapy, a little bit less targeted therapy. And usually after the chemotherapy, the biological age recovers in most of the cases. It really depends on what was used. If it's atracycline. So some of the compounds of chemotherapy are really causing a permanent damage, but we are moving away from those protocols. And it's good to know. It's definitely good to track the biological age, and then, as David mentioned, cellular pathways optimization. So from very, very intensive work in terms of improving muscle mass and nutrition and support, to focus on the bone health, because we know now that a lot of dormant metastases, so the micrometastases that are sleeping, they are actually in the bone and the bone marrow, but not only in the bone marrow, also just in the bone. And so to protect that is very important. And then supplementation. So some of the supplements, actually some of the senolytics might be very helpful. So, the satinib is actually coming from oncology, right? It is a compound that was trialed primarily in cancer patients, as was epigenin, right? And so some of those compounds might actually be helpful. But again, I really don't want to sound generic. It requires somebody who is maybe working a little bit on the crosspath of those fields, longevity and oncology, to suggest the right support, even with compounds, with supplements, on top of the lifestyle interventions, in order to make sure that it's helpful.
Great. Well, thank you so much, Dr. Eva. I know we went a bit over, and thank you for everyone who participated in the webinar from our ecosystem. We're so grateful for you as our clients, and so grateful for your trust in us. And we'll continue to do more of these. Dr. Eva, it's so great to see you. I hope to see you in person soon. Thank you.
Thank you so much for having me. Lovely. Thank you.
Okay. Good night.
Right.